Hey everyone. So here we'll be solving another problem which is move zeros. Although this problem is pretty easy and for those who have a bit of experience, 2, 3, 4 months in this coding, this problem is not even considered a problem for them. But I have seen on Geeks for Geeks interview experiences of many companies, this sort of problems are asked at initial stages. They may be considered as a warm up problem, but they are asked. All right, and when you consider this note, when you see this becomes a bit trickier. Now let's see what this problem says. So you are given an array, you are given an array nums, like this. What you have to do, you have to move all the zeros at the end, all the non-zeros values at the beginning, all the zeros at the end. All right, so one way would be, let's see this. Let's first see our brute force and then we'll see how to optimize this and all sort of things, and see the note what it says. You must do in you must do the solution in place, which means you are not allowed to use any extra space. In optimized version you are not allowed to use any extra space. All right, but forget about optimization, let's focus on brute force. So if you are given this nums array, the main nums array, all right, which is like this. So see guys, if you can divide this, because obviously going for a for loop, make two new arrays, nums of non-zero, I can say nums of 1, and nums of 0 values, nums 2. You can call these variable, you can name these arrays a more like more intuitive names, but this is all right for now. So what will nums1 contain? Nums1 will contain all the non-zero values and nums2 will contain all the zero values. And how will you get them? See, for those who are beginners, a simple for loop from left to right, and if the value is non-zero you'll put them in nums1, if the value is 0 you'll put them in nums2. All right, now what you have to do, let's say you are having this space. You use because see, this nums is already done. This main nums you have broken down into two, so just use this directly. Just, so this was nums and this is also nums itself, it's not nothing new. So what you will do, you will put all the non-zero values at the beginning of this, all the zero values at the end of this. That's it, nothing special, nothing else. So all the non-zero values at the beginning, all the zero values at the end. In this way you will be done with this problem. But guys, as I have said this, see this, as I have said earlier itself, this was your brute force and you were using, see, this is not the extra space. This is, what is this is the initial nums that you are given. You are just putting, you are just using these extra spaces. So what are you doing? You are using extra space here, right? And how many? Two extra spaces, two new extra spaces. All right, so you can get this idea from that the part one, sorry, the introduction video of this two pointer, that if you are dividing this into two parts and you are in brute force and you are getting your solution that, from two parts, like you are putting first part here, second part here. So obviously aim for two pointer, aim for two pointer, and you can easily remove this. But because see guys, why this is required, what this nums1 is doing, it is only carrying it is only containing the values which are not zero. Okay, all right, so you can get all such values using what, the simple if condition. If nums of I is not equals to 0, that's it. This is what this entire space is. We will see this, we will see this, but wait guys, before that you can think of that this extra space is not required, and we'll see that why. But even before that, are you getting this hint that we are using extra space, and these extra spaces are not like dividing them into these extra spaces, it is not taking some hard calculation. You can divide them using an easy if block. If it is not, if it is non-zero, this is like it is this nums, and if else, if you go in else, this is 0. So let's see how in brute force you will do. First of all, you are dividing into two extra space, you are using two extra space, and so you have to aim for what, two pointer as an optimization. Now let's see how will you go for two pointer. As I said, because we are dividing these extra spaces, we are dividing these extra sorry, we are dividing the new this array into two extra space, but we should not divide, because the division is not that difficult. The division is not difficult, it is just depending on one condition. So let me just quickly replicate this array, because I don't want to change the initial, like this one, so that for reference it should be there. All right, 0 1 2 3 4 5 6 and 7. Now let's see, guys. So what were we doing? See, at initial index, in initial index we are putting non-zero values, all right, because the question says that you have to put, at first places you have to put all the non-zero values, in the end you have to put zero values. Okay, and that is what we were doing. When we divided this array into two spaces, the first space was non-zero, not equals to 0. The second space, everything was equals to 0. So depending on this condition, we will go with, like, depending on this ideology, we will go in this. Let's use, because see, initial indexes you will be putting non-zero values. So let's make a variable L, which says what, which says if you're traversing in this array, whichever non-zero value is coming, it should go at this particular index. Initially, let's say L equals to 0, which means you are about, like, you are yet to start the traversal of this array. You are just beginning this traversal. So the first non-zero value will go where? At the zeroth index, all right, because the first non-zero value will, because it will go in the first half, like first part, in initial indexes, and that too at zeroth index, the first non-zero value. So you just have to make sure, what, if you put all the non-zero values at the beginning, zero's value will already be handled at the end. And we will use another variable h, which is just for simple traversal, nothing else, one after another. You can use I, you can use j, but what is of importance? L. Now let's see. Initially h is 0, you can also use I here. Initially h is 0, it is just traversing, and L is making sure non-zero non-zero index where non-zero value should come. This is what L index will be pointing. So let's see. 1 is, and what is our primary condition? Our primary condition is, if this is our if block, if nums of I is not equals to 0, this is what are important. This is what divides this into two extra space. This is what it divides into two extra space, non-zero and 0. If it is non-zero, it is this. If it goes in else block, it is this. All right, let's see. It is 1, it is non-zero. So as we know that it will be as it is, because it should come at 0th index. It is already at 0th index. So increase this by 1. Also h will always increase by 1. So now L equals to 1, what it says, after this you are done, like, till one index you have put non-zero, and now whatever new non-zero element you will encounter, it will come at where? Index number 1. Now see, h equals to 1, h equals to 1 is 0, h equals to 1 is 0. So no problem, we don't want 0, we want non-zero. We are considering about non-zero elements. That is what we'll put at beginning. So move h to one step. See, this is non-zero, all right, this is non-zero. So what you will do, we know that non-zero element should come where? At first index. L equals to 1 at first index. So what I can say, swap this, because till one index, which means starting from 0 till 1 index, which is only 0 index, we have put non-zero values. And right now we know that whenever we encounter a non-zero element, we will put that at L index. So swap them, put 3 here and 0 here. All right, now increase L by 1, which means now whatever non-zero element will come, it will go at where? L equals to 2, because till 2 index, which means 0 and 1 index, they are already, like, non-zero values have already occupied this place. Now new non-zero element will come at index number 2. All right, and also you have to increase this h, because this is just iterator for loop. This will only be for loop. You can use I or you can use j. So 3 equals to 0. Sorry, at index number 3, if your value is 0, we are not considering 0, we want non-zero. Then 4, you will increase this by 4. At index 4, you are having 4 element 4, which is non-zero. Again, swap 4 and 2, index number 4, index number 2. So here it will come 4, here it will come 0. So again, L equals to 3, which means now non-zero element will come at index number 3. It will go to 5. See, 5, okay, again at 5 you are having non-zero. So again swap this, 3 and 5, 2 will come here, 0 will come here, 3 to 4, 5 to 6, which means new non-zero element will come where? At index number 4 right now, and it is 6 is 0. No, we are not considering this. Now 7, index number 7, at index number 7 we are getting 8 is non-zero. So non-zero should come where? At index number 4. And see, why am I saying to swap? Why am I saying to swap if you're not clear about this? Because see, when I was doing, I was not clear. So it's not, there's no problem if you're not getting these smaller things right now. If a beginner, why I'm saying to swap, and why I'm not just saying to override. Let's say you put, because at index number 4, this 7 should, this non-zero element should come. Why I'm saying to swap? Obviously because if you directly put what, if you directly put 8 here, if you directly put 8 here, so here the problem is like you are only getting 0. So you can even avoid doing swap. You can even avoid doing swap. You can just say that I'm getting some good value. I'm getting some value which is non-zero. I can put at 8 index, sorry, at this 4 index. But in make this practice. Why? Because see, you don't want to lose this value. Right now you know the value is only 0. Right now you know that index number 4, the value is only 0, but in future problems these values will differ. I don't want to confuse you right now. That is like, so what I'll say, we don't want to lose the value at index 4. If you put this 8 at this index directly, see, if I say 8 is here, 8 is here, so what is the other thing? You know that we can say 8 to be 0, 8 to be 0. All right, put 0 here. So why I'm saying this, just to keep it simple, I don't want to lose this value 0. I don't want to lose this value 0. That is why I'm swapping them. That is why I'm swapping them, because I don't want to lose this value. At index number 4, index number 7, we know that index number 7, the value should go to index number 4. But what about index number 4 value? I don't want to lose that. That is why I'm just swapping them. So right now if you see 1, 3, 4, 2, 8, all the non-zero values are at initial index, all the zero values are at final index, like sorry, final part, or the next part. So this is how I did this problem. Let's see the solution of it. So this is size, this is L equals to 0, H equals to 0, like this H is iterator, this L will say non-zero values will come at which index. Starting when you are about to start, it will come at 0th index, then it will move forward, while L less than, while H less than N, which means obviously a normal iterator. So this is the basic thing. When you will swap, you know you got a non-zero value, you have to put that at index number L, then you will also increase L plus, you will do L plus plus. See guys, in comments, if you are watching this video, this swap can be removed, this swap condition can be replaced. Do let me know how, because see, the swap condition requires something. Okay, it has its own complexity, because if you traditionally, if you see swapping, it has like 3 to 4 lines of code. But I'm just saying, because if you write your own custom swap function, you know you'll be using 3 to 4 lines of code, and that will also increase complexity, because writing lines of code, it may increase complexity. So just let me know in comments, can you replace this swap function? And my answer is yes, but how can you replace that? Do let me know in comments. And also let me know that, are you liking all these kind of videos? The speed with which I'm like explaining things might be a bit low, but I want to make sure that all beginners like me, and even if you're intermediate, you should get something in the from these videos. How I think, even on these simple topics of 2 pointers, many a times people don't explain the intuition behind it. They are directly like, start from left, start from right. But why when you go from left and right, is there any idea behind it? So this is the way, guys. Let me know in comments if you like this video, and we'll meet in another videos then. Chalo, bye bye.